Welcome, everybody. My name is Andreas, and I'm one of the annual natural gas managers here at the Energy Data Center. And today we'll be taking a look at everything related to natural gas. Here are all the different topics that we'll be covering in today's presentation, starting with the key natural gas trends. In the last 40 years, natural gas production has almost tripled, and natural gas now stands as the second largest gross contributor to global energy growth over that period after coal. The production of natural gas expanded earliest and most quickly in North America and the former Soviet Union after World War II. As you can see on the slide, this trend has continued today, with USA and Russia being the largest producers in the world, combining to make up around 40% of global production. For the demand side, natural gas comprises just under 25% of total energy supply and has many technical characteristics that make it a very useful and flexible fuel and has found uses in many sectors. One of the many sectors has found use is the heat and power production. Trade is also a critical aspect when it comes to natural gas, given the changing regional supply and demand dynamics. An increased focus has been placed on moving natural gas internationally to match excess supply with demand. Moving natural gas, however, requires substantial investment in infrastructure, pipelines to move gas across land and liquefied natural gas or LNG infrastructure to move across water. LNG has slowly been increasing its share of total gas trade, and it's now at 45.8% of natural gas imports. A couple main importers of gas are China for LNG and USA for gas through pipelines. It's also important to note that both liquefied natural gas and natural gas in gaseous state are the same commodity and should not be confused with the various individual oil or coal products. However, LNG trade is also reported separately due to the specialized kind of infrastructure required and its potential to be traded over longer distances. Onto the emissions, natural gas benefits from being the fuel that has the lowest energy per unit burned when compared with coal or oil. It is deemed the cleanest fossil fuel and emits 40 to 50% less CO2 than coal and around 30% less than oil per unit energy burned. Due to this, many people consider natural gas as a key bridging fuel as we transition to a cleaner energy system. Now, here are a couple of interesting graphs to look at. As was mentioned, gas comprises roughly a quarter of total energy supply, or TES. However, this changes greatly on country-by-country basis. On the diagram on the left, we can see that while the share of natural gas in the TES of India and China is very small compared to the world average, around 6 to 8%, the share in Japan, which imports as LNG all of the gas that they use, is 21%. On the other hand, the main producing countries have larger shares, such as the US with a share of 35% and Russia with 52%. On the right, you can see a couple of interesting graphs that show the growing gas use by sectors and also the different regions that produce natural gas and continue to grow. Now, on to some key concepts about natural gas. Natural gas can be defined as a combustible mixture of hydrocarbon gases containing a very high concentration of methane, usually over 90%. But this is not a strict threshold. There's a bit of variability. To some extent, natural gas is very similar to oil, as it is the same organic source material and has comparable geological conditions in which it forms, but it tends to be formed in higher pressure and temperature ranges. It should also be noted that other combustible fuels like coal and oil are classified according to the compositions and gross calorific values. However, natural gas is treated as a single product. The various natural gas mixtures can have gross calorific values that mostly span from 37 to 42 megajoules per cubic meter. And finally, since quantities of gas are usually measured in volume, we need to define the pressure and temperature conditions to measure it. For international data collection at the IEA, we use standard conditions, which correspond to 15 degrees Celsius and 1 atmosphere. Here's an overview of natural gas balance, starting with the supply side on the top, production inputs from other sources, trade, and stocks, and we derive the inland consumption calculated from the supply. And then we have the statistical difference, which is the difference between inland consumption calculated and the inland consumption observed. And now we have the inland consumption observed, which is derived from the demand side and all the end-use sectors. In general, efforts should be made to decrease the statistical difference to ensure that there is a strong correlation between the data on the supply side and the demand side. Taking a closer look now at production, gas can be extracted from a few different places, either from oil fields, from gas fields, or from coal mines. The raw gas that comes out of a well includes a number of hydrocarbons and other contaminants, along with methane. These contaminants need to be removed through a series of chemical and thermal processes to make the natural gas suitable for distribution and use. Some of this gas is flared or vented when it can be processed or transported to a gas treatment plant. And in addition, some of the gas that is extracted is reinjected to enhance production of the fuel. At this step, the concentration of methane in this raw gas is not very high, and it is often referred to as wet gas because it is a liquid-rich gas that has high concentrations of NGLs, natural gas liquids, and condensate, and as a result, it has a relatively high energy content per volume. This extracted gas is transported to a processing plant or a gas treatment plant where it is purified to increase its methane content. From an initial concentration that can be as low as 70%, it is concentrated to very high levels, sometimes up to 99%. Purification consists of separating methane from other hydrocarbons, such as natural gas liquids and crude oil, and the removal of impurities, such as condensates, water vapor, CO2, and sulfur. The resulting gas of this purification process is called dry marketable production, which is the definition that we use at the IEA. Dry marketable production can be further separated into associated gas or gas coming from oil fields, non-associated gas or gas coming from gas fields, and colliery gas or gas coming from coal mines. Now, looking at the overall supply chain of natural gas, our data methodology covers all stages of the supply chain. First, the production of natural gas. As we just looked at, natural gas is mainly produced by extracting a mixture of methane from the underground deposits, but there is a small share of gases blended into the natural gas grid that come from oil, coal, or renewables, such as biogas from renewables being inserted into the natural gas grid. We also collect data on the infrastructure that connects production with consumption. And then finally, here are the many different energy sectors in which natural gas is consumed and used. Trade is, of course, an absolutely critical part of the supply chain that connects the producers with the consumers. And we can see on the slide all of the arrows that connect all of these different elements for the supply chain of natural gas. And we're going to take a closer look at some of these elements a little more in depth. So starting with trade, either gaseous gas through pipelines or LNG over long ocean routes. Pipelines are a very cost-effective way to move natural gas across land or even underwater for short distances, while many interstate and local pipelines exist to move gas over short distances Within countries, major pipelines that cross international borders tend to be larger and less common. In the past few years, due to the Russian invasion of Ukraine, there's been a change in dynamic in which countries have realized the dangers from an energy security perspective of relying too heavily on one single trade partner. This has contributed to the continued growth of LNG trade. And while pipelines are useful where land routes are available, natural gas that needs to be moved across large bodies of water creates a much more difficult technical and economic challenge because the energy per unit volume is just too low. And the solution to that is to cool the natural gas down to the temperature at which it becomes liquid, which is negative 162 degrees Celsius. This liquefied natural gas, or LNG, increases the amount of energy that can be stored in a given volume by about 600 times. As a result, LNG can be more cost-effectively transported in special ships over long ocean routes, but the process for safely cooling, loading, shipping, offloading, and reheating the gas at its destination requires a lot of financial capital. The main components of this process are liquefaction plants, LNG carriers, and then regasification terminals. And as you can see on the diagram on the right, it displays the key trends of global LNG trade, comparing trade in the Northern Hemisphere for the last 2 winters. And here is another graph that very clearly demonstrates the year-on-year increase of LNG imports and exports by region. This highlights the growing relevance of LNG on a global scale. And stocks are critical when it comes to natural gas. Gas storage is often used to shift a constant level of available production to match seasonal demand fluctuations. You can see the drastic demand fluctuation on this slide for OECD Europe. Countries in the Northern Hemisphere typically have a clear demand peak in the winter months when natural gas is used more heavily for heating, and a demand trough in the summer months. The bulk of gas storage happens in depleted gas reservoirs, but there are other geological formations such as aquifers and salt caverns, which can also be used for underground storage. Overall, stocks provide the required seasonal flexibility, resulting in a relatively flat supply. Combination of price signals from the market and regulation drive the operation of the storage facilities, which build stocks during the summer months of lower demand to supply the grid in the winter. Finally, we classify demand into different sectors: transformation, energy, transport, industry, and the commercial residential sectors. Some of these definitions might not be completely intuitive, so we'll have to take a look at a few of them. The transformation sector includes all the demand to convert gas into another energy form. This can be electricity, gas was gas, or many others. The energy sector includes the consumption to support the operations of the sector. For example, natural gas burned for the oil and gas extraction or in a refinery. The main difference between the transformation sector and the energy sector is that in the energy sector, the gas is burned, but it's not transformed into a different commodity. The last one we're going to take a closer look at is non-energy use. This refers to natural gas not used for its energy content, but used as feedstock, produce non-energy hydrocarbon-based raw material. For instance, this could be fertilizers or plastics. Here's a look at some of the various transformations that natural gas is used in. It's transformed into many different energy products, such as electricity or heat, many various coal byproducts, or even some oil products as well. On to the final part of the presentation with key points on data reporting. In the Natural Gas Annual Questionnaire, we ask national administrations to fill a questionnaire on a yearly basis. The questionnaire is designed to capture information relevant to the different steps of the value chain that was presented earlier. And as you can see on the slide, the question is structured into 4 parts: supply, consumption, trade, and infrastructure. which are further divided into 6 individual tables. Following its collection, the data submitted has to be validated to ensure its comparability across time and countries. This involves making sure that the proper methodological standards were used when filling the questionnaire, but also that there is a consistency between the different tables, as well as between the other fuel questionnaires. So you can see some of the questions of this on this slide. We will now look at the individual tables. Table 1 asks for the supply of natural gas. We ask for the data in million cubic meters and terajoules. And we also ask average gross calorific value, or GCV, which let us convert between terajoules and million cubic meters. And we also have the net calorific values, which are typically calculated automatically. When filling in this table, we only count the dry marketable production of gas. So after it's been cleaned of any impurities, any gas vented, flared, or lost or injected is not included in these numbers. That said, gas vented or flared should be included at the memo table at the bottom. For trade, there are 2 points to note. First, we only count gas that crosses the physical boundary of the reporting country. And second, we do not include transit or re-exports within this. So if gas comes into your country, travels through it, and to another country, we don't include that. Only gas that's consumed within your country should be considered as exports, as imports. In the first half of the consumption tables, we have table 2A, where we only ask for data in terajoules. The million cubic meter conversion is done using the gross calorific values that you provide in table 1. The table is split between consumption within the transformation sector, where gas is transformed into electricity or heat, the energy sector itself, where it's consumed to support production or transformation activities, and distribution losses. In the second half of the consumption tables, table 2B, we ask for data in terajoules on final consumption within sectors such as transport, industry, and other, split into more detailed subsectors. We distinguish between the energy use, which is when gas is used as a fuel, such as when it's used for residential heating, versus when used for non-energy use, such as when it is used as a raw material, for example, to produce hydrogen. Within the consumption tables, there are a few technical aspects to transformation when we produce electricity and or heat. Typically, there are 3 types of plants: electricity plants, heat plants, and combined heat and power plants. These are further divided into 2 types. These are main activity producers, which are entities or companies whose sole or main purpose is to produce and sell electricity or heat, and auto producers, which are entities that produce electricity or heat as a byproduct of another primary product or activity. Within transformation reporting in table 2A, we want to avoid counting the electricity or heat, which is consumed by the auto producer for its primary activity, as this is consumption, so it should be reported in table 2B. In the transformation sector, we should only be reporting the consumption for electricity or heat, which is then sold onwards by the auto producer. Now we see tables 3 and 4, where we report imports and exports respectively. The IEA collects data on total gas, as well as amounts of LNG traded, and we can easily calculate LNG trade from these values, as well as pipeline trade. We ask for details on the country of origin for imports, as well as the destination for exports. The total should equal that reported in table 1 in the supply. As we mentioned before, we want to report the ultimate origin or the ultimate destination of gas being traded. And if the gas imported or exported is merely transit, then it should not be included. And finally, we ask for data in both million cubic meters and terajoules. And finally, here are a few data quality checks that we should be mindful of that are specific to gas reporting. First, we treat gas as a single product, when in fact there are often gases with high and low calorific values used in different gas systems. Instead, we ask countries to report the average calorific values for the gases. Second, there are technologies and innovations within the natural gas sector and around financial products and LNG trade, which means there's now increasing amounts of trade and more transit trade, which makes it difficult to exclude this from reporting. Another problem that we sometimes encounter it's issues around measuring gas volumes. We at the IEA use standard conditions, but sometimes data is reported to us under different conditions, which requires us to convert these values to make them comparable. And lastly, it is essential to report the correct calorific values with data in terajoules, sometimes being reported in net calorific values rather than gross calorific values. Here are the various resources that are very useful if you would like to take a closer look at them, especially the United Nations National Recommendation for Energy Statistics, or IRES. And here are even more resources if you have the time. Thank you very much for watching.